In this video, we're going to add and subtract rational expressions. And before we do that, don't forget about the rules for fractions, because rational expressions are just fractions. So if I asked you to add 1/2 and 1/3, you would say, geez, Lindsay, I better not do that until I have common denominators, right? So you would get yourself some lovely common denominators, and then you could add those fractions. And the denominator, when you're adding, stays the same. It's sort of like units. I have 3/6 and 2/6. How many sixths do I have? I have 5 of them. So my denominator stays the same, and I just add right across my numerators. Okay. Subtracting works exactly the same way because subtracting is just adding in disguise. So if my denominator is already the same, there's so little to do here. I'm just going to add the top. So I'm going to add on the top 3 plus x, and my denominator stays the same. Nothing else to do except maybe check if there's anything I can cancel out in order to simplify, which there isn't. So we're done. Now, when my denominators are not the same, I need to make sure that I make them the same before I do anything else. And there's a tendency sometimes to say, oh, I'll just multiply them by each other, right? And you can. Let's use some real numbers for a minute, though, to look at this. If I did 1/10 plus 1/15, and I said, I need common denominators, I'll use 150. You're, of course, allowed to do that. It's just that everything gets really big. And especially if we ended up having variable terms, there's more chances to make mistakes as we're multiplying these big terms. What I could do instead is I could say, 1/10 is the same as 2 times 5, and 1/15 is the same as, that's a 3 times 5. So actually, they're so close to being the same number. This guy's missing a 3, and this guy's missing a 2. We're just going to make them both into 30ths, right? So I'm going to do a really similar thing here. I'm going to try to look first for what they have in common and see if there's anything that I don't need to multiply again. So I'm going to take for my x minus 8 and look for a greatest common factor in that. And there is 4 goes into both of those things. When I divide that out, I'm left with x minus 2. And that makes me so happy because the denominator over here is x minus 2. And in order to get these to be the same, all I have to do is multiply this one by 4. And now they'll match. I didn't have to multiply this fraction by anything because I can tell that this one getting multiplied by 4 is going to fix all my problems. So now I have 2x times 4 times x minus 2. Over here I've got 4x squared times 4 times x minus 2. My denominators match. So on the top, I've got 2x plus 4x squared. On the bottom, I have 4 times x minus 2. Let's just double check if there's anything I should cancel out of that. This looks like it's going to be 2x times 1 plus 2x. And on the bottom, 4 times x minus 2. So I could actually cancel that, 2 divided by 4 could cancel to just 1/2. Is that 100% necessary? It's going to depend on what you are being asked for and looking for in your problem. But it is going to make it as simplified as we can get it. Here again, I could multiply by x here and by x squared here, and now I have everything in x cubed. But why? Because I can tell from the top, I can turn an x into an x squared, and then I don't have to mess with the x squared at all, right? So I'll multiply by x over here, and now I'm going to have matching denominators, which I love. So I've got this guy plus this guy, and I'm just going to add my numerators together. And then I should kind of clean this up and see if there's anything that'll cancel. This guy's turning into x squared plus x plus 3. And on the bottom, I just have x squared, and nope, nothing to cancel. All right, so now's the part where we have to do more work to make sure these denominators are matching. One is x plus 1, and the other is x plus 2, and I cannot take those two things and just easily make one into the other. I can't add 1 to x plus 1 and turn it into x plus 2. If I just added 1 here, I'm changing the value, even if I did it on the top and the bottom. adding on the top and the bottom changes the value in a way that multiplying on the top and bottom does not. If you keep in mind that like 2/3 is equal to, if I multiply by 2 on the top and the bottom, that equals 4/6. But 2/3, if I added 2 on the top and bottom, that is not equal to 4/5. That's like an entirely different thing. So I can't add or subtract on the top and bottom of a fraction and maintain its value. I can only do that with multiplying and dividing. And again, that's only because dividing is just secret multiplying. So here, I really can't turn these into each other without really multiplying them completely by each other. So gotta do it. And if I multiply by x plus 2 on the bottom, I absolutely must multiply by x plus 2 on the top. Over here, if I multiply by x plus 1 on the bottom, I absolutely must multiply by x plus 1 on the top. So I've got 4 times x plus 2 over, and for now I'm not going to FOIL this guy out, I'm just going to leave him be, minus 2 times x plus 1, and that same denominator. So this guy's going to come all together to be one big fraction with that same denominator. On the top, I've got that 4 times x plus 2 minus 2 times x plus 1. And now I can distribute those guys out, simplify it down, see what I'm left with. 4x plus 8 minus 2x minus 2. Whole thing is still over this guy. And let's see, what can we do here? 4x minus 2x, 8 minus 2. It doesn't look like I'm going to have anything that'll cancel out, but I'm still going to take out a greatest common factor on the top just to double check, because we would hate to leave something that could have been canceled. Looks like it's going to go down to 2 times x plus 3 over that x plus 2 times x plus 1. Again, could you FOIL out the bottom? Yes. Do you have to? No. This is helpful right now as it is factored. We can see what would make the denominator equal to 0, which would be very bad. And it's going to help us when we are graphing these later when we're working in rational functions. So here we are, 2 denominators that look totally different. But before you start messing with them, factor, factor, factor. So I'm going to see if I can factor this quadratic right here, because that might help me figure out, do I really need to multiply this whole trinomial with this whole binomial and get a big, big thing? And again, more opportunity for error. Hopefully not. I need 2 numbers that multiply to positive 8, but add up to negative 9. And just as a quick reminder when you're doing this, a positive and a positive multiplies, but also a negative and a negative will multiply to a positive. So this is going to be x minus 1 times x minus 8. And now we're going, oh, thank goodness we did that. Because factoring first, let us see, we had a factor in common already. We did not need to turn this into an enormous thing with trinomial times a binomial, all those many terms. All I need to do is multiply this guy over here with x minus 1 on the top and bottom, and that's going to make my denominators equal. So I've got x on the top on that one, and 2 times x minus 1 on the top on this one. Denominators are equal, so I can just combine them. X plus 2 times x minus 1 over that lovely common denominator. So I've got x plus 2x minus 2 over all of that. So it's 3x minus 2 over my denominator. Nothing's going to cancel from here, so I'm all done.